In example 13, we're going to be changing logarithmic expressions to expressions involving only natural logs. Now, the change of base formula. The change of base formula can be used to evaluate a logarithm with any base and then for any positive real numbers, m, b, and n, where n does not equal 1 and b does not equal 1. We can rewrite the log of base b of m is equal to the log of base n of m divided by the log of base n of b. Now it follows the change of base formula can be used to rewrite a logarithm with any base as the quotient of the common or natural logs. So we would have the log of base b of m, which is equal to the natural log of m divided by the natural log of b, and the common logarithm of b of m is equal to the common logarithm of n of m divided by the common logarithm of n of b. So we want to be able to change the log of base 5 of 3 to a quotient of natural logarithms. So given a logarithm with the form of the log of base b of m, we're going to use the change of base formula to rewrite it as a quotient of logs with any positive base n, where n cannot equal 1. So step 1, we're going to determine the new base n, remembering the common log of x has a base of 10, and the natural log has a base of e. Number 2, we're going to rewrite the log as a quotient using the change of base formula. For part A, the numerator of the quotient will be a logarithm of base n and argument m, and the denominator of the quotient will be a logarithm with base n and argument b. So because we'll be expressing the log of base 5 of 3 as a quotient of natural logarithms, the new base n is equal to e. So we rewrite the log as a quotient using the change of base formula. The numerator of the quotient will be the natural log of the argument 3, and the denominator of the quotient will be the natural log with argument 5. So here we have our formula. It's going to be the log of base b of m, which is equal to the log of m divided by the natural log of b. So let's apply the change of base formula using base e. So we have the log of base 5 of 3, which would then equal the log of 3 divided by the natural log of 5. Okay, and then what I want to point out are the answers. So we've converted it to natural logs. So if I take the natural log on my calculator, the natural log of 3, and divide that by the natural log of 5, then that would give me the approximation. If we round that to 4 decimals, it would be 0.6826. Okay, now also in the definition, we can rewrite them as common logarithms. So let's see what happens when you use common logarithm, meaning log instead of ln. So if we have the common logarithm of 3, and then divide that by the common logarithm of 5, then we get the exact same answer. So that is the reason why that in the definition, okay, you could use either the common logarithm when you change the base or the natural log. So change of base allows us to be able to then figure out the information on a calculator, because the common logarithm only has a base of 10 and the natural log only has a base of e.